flagrant violation of, when they said I could come speak, they didn't tell me to do the how to give a talk. I'm going to jump in on that topic anyway, because there's a couple things that you're not supposed to do. You're not supposed to spend forever talking about yourself. I will try to abide by that rule, only to say that, hi, I'm Josh. I work for a place called Endpoint, and I'm one of the guys that answers the phone when you call up and say, I have this database and I'm not sure it's working, can you help? There will undoubtedly be other personal tangents throughout this just because that's how I roll, but we'll call that good for now. The other thing you're never supposed to do is do a live demo. You're familiar with the blue screen of death that Steve Ballmer had to fight with in the now famous YouTube video saying, here's wonderful Windows 95 or whatever it was. So we're going to do that. And if it causes problems, then go back to lunch in 10 minutes or something. Taco Bell's that way. And if it does work, that would be cool. Those of you that have some exposure to Postgres specifically will probably find that at least some of this is review. I really don't feel bad if you fall asleep or walk out or whatever. If the room gets empty, I'll probably go home and that would be okay. I said I work for Endpoint. I should publicly say thank you, Endpoint, for letting me show up and do this today instead of sitting at my desk cursing at my bad internet. So, like I said, I'm one of the guys that answers the phone when you say, I've got this database and it doesn't work right. Can you fix? And we end up doing a lot of that. My hope with this presentation is to go through some of the things that I find people have done wrong. And there's a lot of them. I will get on some new customer's system and they'll say, well, we did this and none of us really knows what we're doing. We're web developers or we're whatever. And lots of people have done this and that's fine. That's perfectly all right. At some point, that can cause you growing pains. And it helps to bring in somebody that is maybe not a web developer, and maybe a database guy. I try to be a database guy. And that can look at these things and find some of those problems. And I hope to go over what some of those are. So you may have used bad hardware. You may have used MySQL. You may have set something too high. And all of these are problems that can be fixed, some of them more easily than others. We're going to do this, like I said, as a live demo. There aren't slides. So what we've got here are a pair of Vagrant machines. You're familiar with Vagrant, so virtual machines. And are you familiar with terminal multiplexers with screen? Okay, we're looking at two systems here called Alpha and Bravo. And when Alpha is all blue like this, that means we're looking at Alpha. When Bravo goes blue, we're looking at Bravo. Okay, we're good? So we've got two machines. Alpha is our principal. Alpha is the one we'll be playing with most of the time. These are Ubuntu 14.04 boxes. And so far, I've installed a few packages on them and then otherwise left them stock. So we've installed Postgres. We've installed a bunch of packages to go along with it. I'm a Postgres person. I like Postgres. It's worked well for me. It has its drawbacks. It has its good points. It's not MySQL. That's a good point. And so we'll be using Postgres. There are other technology decisions that you could make. Many of them would be wrong. Some of them would be okay, too. All of this will be open source software. So all of this is stuff that you can freely download and hack on and break to your heart's content. All of it is stuff that I've used for various projects. It's not necessarily perfect for the idea that you have that's going to take over the world. But there you go. Given that disclaimer, okay, we have this brand new Postgres box called Alpha. When we installed the Ubuntu Postgres packages, it created for us what Postgres strangely and irritatingly still calls a cluster. A Postgres installation is known as a cluster for historical reasons that become very confusing if you actually want to make a cluster of Postgres servers. Ubuntu makes one for us. It lives right here. And I'm struggling with my keyboard today. In this directory, this is legible? We're good? Okay. In this directory called main live almost all of the files for a Postgres installation. This is the way Postgres works. Everything pretty much lives within one directory, and if you want it to go away, you stop all the Postgres processes, you delete that, and you're done. So it's made one for us. We're going to pretend that it hasn't. Well, no, we're not. We're going to explore for a little bit. First of all, the Ubuntu way. Ubuntu has taken the Postgres packages and put wrappers all around them so that it can do things its own way. In some ways that's helpful. You get logs in a consistent place. You get config files in a consistent place that kind of sort of follow the way that Unix was actually made to be. This does all work on Windows if you want, but that would be a poor technology choice. We'll be listing these technology choices as we go through. Because of the terminal width, this looks kind of funny, but if it were down to like normal, I'm sitting in front of you size, this would look pretty normal. This tells me that I have one Postgres installation on this system. It's called main. It's running version 9.4 of Postgres. It's listening on port 5432. It is running. It is running as the Postgres user, and it lives here, and there's the logs. Let's create a new one, just for kicks. And we sit here and we wait for a moment while it thinks. This is, as I said, a virtual machine. It takes a little while. OK, we've created a new Postgres cluster. It's called new cluster. New cluster. It's also version 9.4. It's running on port 5433, and it's not running right now. So we're going to start it. We'll use the right keyboard. If I use this one, it doesn't work for some reason. Let's see. Like I said, we're starting really basic here. These are all, this is the right thing to do when you get started. Install it, set up a cluster, start playing with it. So I've told it to start. It now says, if you see next to port 5433, it says online. So we're now running. And I'm going to log into it. Who's played with Postgres before? Am I just telling this to hundreds of people that already know what we're doing? OK. So I can type in queries. I can see that I don't have any tables. I have one user. This is my new Postgres instance. When you have a new database instance, what do you do with it? You play with it for a little bit and say that it works. What happens next? It breaks, OK? What breaks about it? The first thing that tends to break for me is I try to hook something up to it and find that I can't. Right, exactly. So one of those problems is I'm going to actually, now we'll keep playing. OK, here's my new Postgres instance, except that I wanted the config files, which don't actually live there because Ubuntu is the way it is. So OK, the first thing that we want to do is make sure that we can connect stuff to this. Postgres has a config file, which in this case is going to live here. And I'm having a hard time typing like this. I apologize. You can spin them on here. You know, I could actually. That would be. You have saved the day. OK, this is a Postgres config file. We're going to do that to make it look nicer. And there's a whole bunch of stuff in here. You don't need to know what most of it is. One of the things that people really like to do wrong, incidentally, is fiddle with that value. We'll talk about that in a moment. One of the first things that people will do when they've set up this brand new cluster and they aren't really sure what it's doing is look through this and say, oh, huge pages. That sounds like a good thing. Maybe I'll turn that on. Prepared transactions. I want my transactions to be prepared in case the zombies come. We probably want a lot of those. Let's see. Vacuum should be inexpensive. We don't want it to cost very much. So we'll make this negative. And they just kind of change stuff. That was a bit facetious. But they change a lot of stuff. So shared buffers is a fun one. Let's do 128 gigs because we want lots of buffers. So people have changed this stuff. The one that we really wanted to change when we started is this one. Postgres, by default, listens for connections in a couple of ways. This is slightly different on Windows. Again, that would be a poor choice, so just go with it. Postgres will listen for TCP connections and Postgres will listen for Unix socket connections. And it has some directory somewhere, and this changes from installation to installation, which gets irritating, a directory somewhere where it has a little pipe open, and you can connect to that pipe. And actually, that's by default how you connect to Postgres. So when I'm in here, I'm not actually going to save those, by the way. When I say this, I've told Postgres I want to connect to port 5433, except I'm not actually connecting to a port and TCP and all of that stuff. I'm connecting to a Unix socket. There's a file called 5433 somewhere, or a file with 5433 in the name somewhere on the file system, and my little client has found it, and my little client is connected. So I can connect to Postgres. If I happen to be on the same machine, I can connect over a local Unix socket. I can connect over TCP. And the first thing that I typically want to do is I've got a database server here and a web server here. Web server wants to talk to database server over TCP. And when we try it, like if we go to Bravo, that would be the wrong command to type. It says I can't connect. Do you see blue? We're now on Bravo. Then we go back to Alpha. Just unless we randomly type a P because we're not very good with the keyboard these days. We're going to fix this. We're going to get Postgres listening.
Is some of this stuff distro dependent? Like where some of these config files are and stuff?
Yeah, so I'm showing you the Ubuntu way. And I'm tempted to go into the everybody else way for a little bit. I'm also tempted not to, only because this is kind of the really basic stuff. You do it once, and then it just runs forever. You can get the commands out of the documentation. A default, totally stock, built from source or whatever, Postgres installation will just live in one directory. And if you want to get rid of it, you get rid of that directory, and you're done. All the config files live within that directory. Anything that you might want to touch lives there. Ubuntu does things differently so that it can have all of its config files in the etc file system, which admittedly is nice if that's what you want. And actually, for purposes of this demo, we're going to do a little bit of both. And so anyway, so you'll kind of see both, just because of the nature of some of the software we're using. So right now, Postgres is listening, in fact, Postgres right now is not listening on an interface that anybody else can get to. It's listening on its local interface and nowhere else. We need to change that so that Bravo can connect. That would be the wrong keyboard again. The easy way to do that is this. And in this case, we have to restart. And now if we go to Bravo, it should connect. No, it doesn't, because this is the next thing that you have to do. When you're trying to connect to Postgres, it has this thing called host-based authentication, which means that you can control not only is Postgres listening on this interface or not, you can control, well, I'm listening on this interface, but only user Joe can log in, and he can only do it from this IP, and he can only do it to these 3 databases, which can be really helpful if that's what you happen to want. So we have to go back here. That's controlled with this file. And what I'm going to, okay, so I said Postgres listens for Unix sockets and it listens for TCP connections. You see in here a whole bunch of rules. Local means a Unix socket. Host means a TCP connection. And I can create a whole bunch of rules for who can connect over Unix sockets, who can connect over TCP. This bit starts to get a little scary because I say that often, cool, I wonder if that's new for 9.4 or if I'm just stupid. Often this will, you'll install this and this will say trust, which means that the Postgres user can log in to anything, and somebody will look at this on their new installation and say, I don't want the Postgres user to be able to log into anything and to just trust him. I want him to at least put in a password, right? Because that's scary, and the Postgres user runs everything. Here it says peer, which actually means I have to be running as the Postgres user on the operating system in order to log in as Postgres. May I suggest that you don't change this? The reason is, by default, on a Postgres instance, you can get to be the Postgres OS user, and you can log into Postgres and you can do whatever you want. over a Unix socket. You can't do it from some other box on the network. You can't do it from anywhere else. You can do it as the user on the operating system who happens to own all of the data files and can look at them anyway. So when you change this, saying, I'm now super secret and secure, really you just make it hard for somebody like me who wants to come in and change things and has to ask you for the password. So don't change that. What we do want to do here is we want to let Bravo log in. Now, Bravo's IP address is going to be on a 1041 network because that's what I made it. Last time we changed this, we had to restart stuff. Now I just have to reload to make this new rule take effect, and now I should be able to log in, except that I need a password. Why do I need a password? Because right here, and you can't see it because of the line wrapping, I chose the MD5 technique, which means that I need a password. Just for kicks. This is not a good thing to do if you plan on actually going live someday. Okay, we've now logged in. And we're living, this is just sort of some way that we know that we're actually connected to the right database, is that we're in a directory called new cluster, which is something I made up specific for this purpose. I'm doing this to just kind of give you some very basic familiarity. Many of you have this already, so let's move a little bit beyond some of the basics. I'm just going to do this. I'm going to drop that cluster because I don't want it anymore, so there. Okay, we still have the default cluster that Postgres is installed. The next thing you do, after you make it so that other stuff can connect, you might start to think, well, gee, now that everybody can connect, I want security on this. Frankly, we're not going to talk about such things a whole lot, because that could be a whole crazy, stupid live demo in its own, and I don't want to. Suffice to say that you can create database users, and they can inherit from each other, and they can have access to objects, and you can control all of those sorts of things, and that's a demo for another time. But the next thing that you start to think about is, well, I'm going to model the entire world's economy in my new exciting app that I'm making because I'm special and that's how it's going to work. I actually had a guy call me up once that he wanted to scan every receipt in the world, pretty much, and use it to model the world's economy on a Postgres system and PHP. I had written a blog post on two-phase commits. Are you familiar with two-phase commits? So it's the idea of having multiple players in a transaction rather than just one computer says, okay, here's my transaction, I'm going to do X, Y, and Z, and then I'm going to commit. I have a bunch of players all in one transaction, and they commit all at once. I'd written a blog post on some ways of doing that and some transaction manager software, and this guy called me up and said, can I write a transaction manager in PHP? And we had a really fun discussion for a moment. He talked about how he wanted to scan the world's receipts, and he was going to model the economy of the universe in his app. I don't think it worked, but he hasn't called me back. So the next thing you end up wanting to do, if you are concerned about being able to scale this decently, and you should be, especially if you're using Postgres, because the default settings in Postgres are extremely conservative so that it doesn't barf when you run it on, say, a crappy little virtual machine on your laptop in front of a bunch of people that will lynch you if it doesn't work. So the settings are extremely conservative, and you want to kind of beef them up a little bit so that it runs on your exciting new 24-core server. So one of your options is to stare at that config file for a little bit and decide that you want your transactions prepared because that's important. The other option is to have somebody that's probably smarter than you and has encoded at least some of his knowledge in a script to do it for you. If you call us up and you say, I would like you to look at my database settings, this is probably not what we're going to do. We tend to be unreliant on script. If you don't know what you're doing, you should rely on the script and you should be happy. There's this, I got this from an Ubuntu package. I have roomed with the guy who wrote it for a while. It's called PGTune, and its job is to go through your system. Essentially, it assumes that Postgres is all that's going to be running on your server, and if it's important enough that you're running PGTune on it, that's probably the right thing to guess. It looks at what your server's got on it, memory and disk space and all kinds of stuff, and guesses at what are probably the right config options for you. So we're going to, if I can type. All you have to say is, here's my config file already. Here's the file that I want you to make it all better in. And it thinks for a while. It has gone through and it helpfully added everything that it came up with to the bottom of the file. So I can go and I can look over all of the exciting decisions that it's made. I don't want to spend a whole lot of time on this. You could also have an entire presentation on how to tune Postgres, and that isn't my purpose today. My purpose today is to suggest that it's easy to look at some of these and say, well, I want my checkpoints to complete. I'm not sure what a checkpoint is, but I want it completed. And so I'd better set its target really high because I know what that means. Or effective cache size. Well, I want a lot of cache, and I want a lot of buffers, and I'm probably going to need to work with more than 6 megs of memory. So I'm going to set these numbers really high. The problem that occurs is that really messes things up. So for instance, 2 or 3 times in recent memory that I've gotten onto somebody's system, and they've seen the shared buffers setting. And they know, like a lot of people know, that shared buffers is a big chunk of shared memory that all Postgres processes have access to. But they maybe didn't know that through the caching that Linux does for you anyway, assuming you're using Linux or some Unix kind of system, they also have access to all the rest of that memory as well. And so the problem occurs that every time you checkpoint, which is where you take anything that's happened in the last little while and flush it to disk to make sure it doesn't get forgotten when that idiot server guy trips over the cord again, when it writes all of that stuff to disk, it has to write the full extent of shared buffers. And so if shared buffers is 20 gigabytes, then every 5 minutes or so it's trying to write 20 gigabytes of disk, and I/O gets really, really bad. I'm mentioning that specifically. It's boring, but that is a specific mistake that I've seen lots of people make, and in very recent history. So please don't make that one. There is a lot of, in shared buffers particularly, and in lots of other Postgres tuning options, there is more of art than science in coming up with proper values. Shared buffers specifically depends an awful lot on what operating system you're using. If you set it too high on Windows, everything goes to pot even more than it already was because you were on Windows. If you set it too high on anything, I/O gets really horrible. And PGTune knows about that. We do too if you call us. We're endpoint. PGTune knows about that stuff, and it will take care of these things for you. Okay, we've set a bunch of settings. PGTune, we hope, is smart enough to realize that I'm on a crappy little VM and I really don't want to choke. So let's see what we can do here. Eight. And some of these settings we have to restart to make this work. So let's see if this works. Okay. Okay, so we can see that this worked. This is a favorite technique of mine, incidentally, when you change something, is change it, restart, reload, whatever you've got to do, and then check to see that your change actually took effect. Because sometimes it won't for reasons that you may not understand. A friend of mine, a coworker of mine, and I did that once to a customer's, and we wasted 5 minutes or something, not a whole lot of time. There was a particular bug that we uncovered in Postgres that if this particular setting is messed up, then nothing else gets loaded, and that was a problem. A lot of times, if I screw up one setting, it will load everything else that it can, but that one setting, it will complain about it in the logs, and if you don't look at the logs, then you don't know what happened. Anyway, so we have just used PGTune, and our database is now the new hotness and extremely fast, especially considering it's on a crappy VM. Okay, we've got a database. We've got people from the outside world able to access it. We went to that other mythical presentation on Postgres security, and we implemented everything that they said except for the stupid things. So it's all super secret and secure. And now the problem that we have is that we have these web servers. A client of ours has a serious load during the holiday season. So holidays are a really big time, like 40% of their traffic or whatever happens just during 2 or 3 months. The problem with that is that every new session on their web servers wants a connection to the database. And Postgres in particular cares about that kind of thing. Postgres has this setting that there's a maximum number of connections you can have to the thing simultaneously. And establishing, setting up and tearing down one of these connections is a difficult deal. So we put in a connection pooler, right? You've played with connection poolers? You know what a connection pooler is? A connection pooler is a spiffy thing that opens up a bunch of connections for you of difficult, slow, hard to set up connections for you and keeps them open, and then just lets you use them. You connect to it in some very quick, very easy, simple way, and if you need one of the slow connections, you grab one and you use it, and then you release it to the rest of the world again. You do release it to the rest of the world. Just, that's an important step. I worked at a place once. This is that background that I'm not supposed to share. Remember rule number 1. I worked at a place once. We were a government contractor, and we wrote part of the software, and Raytheon, the folks that make guided missiles and stuff, wrote another part of the software. There's a reason that the Raytheon contractors we worked with weren't on the guided missile team. They didn't want them. So I started this job, and Raytheon had forgotten to give up its database connections. So you get into Raytheon's part of the app, they get a connection, and they keep it forever. And somebody else gets into Raytheon's part of the app, and they get a connection, and they keep it forever. And it didn't take very long. This is slow and efficient government stuff, so it did take a while. But it didn't take really terribly long before all of a sudden Raytheon had all the connections and nobody else could do anything. And so Josh spent the first couple weeks of his employment on the living room floor in front of a laptop, waking up every 2 hours to restart the whole thing until Raytheon figured out where they weren't giving up their connections. It was a beautiful time. So you will give up your connections when you're done with them. We're going to install a connection pooler. There are several of these that you can use in the Postgres world. Those of you using Java, there's hundreds of them. If you have an application server like a Tomcat, JBoss, that kind of thing, there's one built in for you. Django now has connection pooling built in. We're going to use our own. This is something called PGBouncer. It's another thing that I installed from packages just onto this system. So it's not a compile your own kind of thing. You can if you want, but what I'm saying is you don't have to. And PGBouncer is a Postgres-specific connection pooler that works really quite well. So it has this lovely little INI-style config file. This is the stock file that comes straight out of the package with a couple of exceptions. I've added this line. So here I have a list of databases. These are all of the databases that PGBouncer is going to know about. I'm setting up PGBouncer here, and I'm going to say, PGBouncer, you're going to front these 5 or 6, or in this case 1, databases. The database is named this. It lives on this server. It's listening on this port. In this case, I just accept sensible defaults. I have a Postgres database in my new cluster that I created, and I'm just going to front that with PGBouncer. PGBouncer also, I think I changed this actually. This is the same as the Postgres listen address. PGBouncer's one major complication that I run into is that you log into Postgres and it has to set up your connection, and one of the things that it does for you is it authenticates you. PGBouncer is not going to just hand off that authenticated connection to just anybody unless they have also authenticated you. So you have to tell PGBouncer how, when somebody connects to it, how to authenticate that person. And that can be a little bit difficult. So we're going to look at this just a little bit. See how difficult that was? If you have a system that has a bunch of different users, they have passwords, that kind of, this is all stock, pretty simple laboratory environment stuff. This file format, to tell you the truth, I don't remember what all three fields are. This obviously is username. One of these is a password which can be encrypted, hashed, and I don't remember what the third field is. There is, however, a PGBouncer script that will connect to your database, look at all of your users, and create that file for you. Postgres makes a hashed version of the password available for super users to look at. That's okay, it's still hashed. Anyway, relatively, it is MD5, so there might be some problems there. Anyway, it's able to create this file for you. And that gets a little bit, well, I also have set this to trust here, so that's another just laboratory environment, make this work quickly. What I'm getting at, I'm kind of rambling, what I'm getting at is that PGBouncer does require you to do a little bit of work to get the authentication right. I will also warn you that PGBouncer, as I said, is a Postgres-specific connection pooler. If you happen to be running, say, Django that has a built-in connection pooler, and you try to have those connection poolers live on top of each other, things can get kind of strange. It's probably not a good idea to nest connection poolers unless you understand them well and want to spend a lot of time looking closely at them. And you have a good reason. Why would you want to do that anyway? Okay, we've created this thing called this PGBouncer INI file. It's listening on port 6432. Let's see if it works. I think the PGBouncer service was already started. Okay, with PGBouncer, we are not connecting over a Unix socket, so I'm going to put in a host name to connect to. I'm going to put in a port. I'm going to connect to the Postgres database, and it works. We know that I'm now going through PGBouncer because I can do this. I can connect to a special PGBouncer administrative database, and I can issue all kinds of weird commands. I'm going into this because it's been my own experience, maybe just from dealing with Raytheon, that it's a really good idea to know how to monitor your connection pooler. So again, the deal here is that if I have 400 connections on a web server or on 17 web servers that want to connect to Postgres, they establish 400 lightweight, simple TCP connections with PGBouncer instead. And PGBouncer establishes 80 or 100, anyway, some smaller number of heavier weight connections to Postgres itself, and then hands off those connections as necessary to the different Postgres users that need them. So this view is boring right now because there's all of one connection in the whole thing. But this view is what tells me what's going on. It tells me how many active clients I have. I have one user logged into the PGBouncer pool. That's an active connection. I'm actively using it. I don't have anybody waiting to get a connection. So if I have 400 users here that could potentially want a connection and only 80 connections that they can use, there's the possibility of running into a situation where one of those 80 connections is not available. And I have to wait for a little while. So right now I'm not waiting. This is an important thing to pay attention to. A lot of these are what status you're in as you're logging into the database. Are you in the middle of logging in to the database? You can tell PGBouncer to test new connections to the database as it establishes them. Am I in the middle of testing those? We don't need to get into what all of those mean. I want you to know this because it is fairly helpful to be able to monitor this stuff.
Quick question. Is PGBouncer able to load balance between read-only databases, or is there a different tool you would suggest for that?
So there's another connection pooler that does a lot more of that stuff. It's called PGPool. My own experience with PGPool has been fairly negative. However, there are lots and lots of people that have had positive experiences with it as well. And my negative experience was not entirely PGBouncer's fault. It was colored by things like client expectations that hadn't been properly managed and available time to work on things and other crises that appeared at the same time. PGPool is sometimes billed mostly by its supporters, so there's that. But anyway, as the Swiss Army knife of Postgres stuff. So it will let you connection pool. It will let you load balance between read-only servers. It will do its own form of replication if that's what you happen to want. It does a lot of stuff. As I said, my own experience with it was very negative, but also very limited. PGBouncer has been very good for what I've wanted. I have one major concern about PGBouncer and PGPool and any connection pooler that you don't have to pay attention to, and that is that I'm not convinced. I haven't actually run into this problem in practice, so take all this with a grain of salt, but I'm not convinced that the pooler is going to know for sure when it can hand off a connection to somebody else. So if I'm one of the 400 connections from the web server, and I start up a transaction, for instance, and I have this session with the database with a transaction involved, and then my connection to the database gets handed off to somebody else, then what they're doing happens in the middle of my transaction. And then maybe I get it back, or maybe I get another one back that doesn't know anything about my transaction, and that could be a problem, right? Does that make sense? PGBouncer has, that's a very simple case. PGBouncer handles that fine. I haven't seen that specific problem. I have this, I can't label it as anything other than paranoia, really, because I haven't actually seen this in practice, but I have this paranoia that more complex scenarios it might not handle very well. Within PGBouncer, let's see, there is a pool mode. This handles exactly what I'm talking about. You can set PGBouncer to its heuristics to know when to hand off your database connection to somebody else. It can be at the end of your session, as it is in this case, meaning that when I log in to PGBouncer, I get a connection to Postgres that's mine until I disconnect again. That might seem stupid. The advantage there is that connecting to Postgres takes quite a bit of work. I mean, it's a heavyweight sort of thing, and it takes some time, whereas connecting to PGBouncer is really fast. And so that manages to amortize out a lot of that time spent establishing connections, and that's useful for those purposes. Also, a lot of applications, you know, your web app, you connect to, I'll pick on Django again, you connect to Django, it needs a database connection to render your page, and that happens in half of a second, or however long it takes to render your page, and then it's done and it disconnects from the database again. And so this process of connecting and disconnecting from the database, you aren't going to stay established with a connection to PGBouncer for a long time. You're not going to hijack a Postgres connection for a long time. You can also set this to transaction mode. That way PGBouncer supposedly releases pays attention to your transactions when one starts and when one stops, and releases the connection after that transaction stops. There is some possible disadvantage there. In Postgres, at least, you can set up temporary tables. Those are visible only to your session. So you log in, you create a temporary table, you maybe do some transactions, you end a transaction, PGBouncer says, oh, you can release your connection now. When you get your connection back again, you might have a different session and you can't see your temporary table anymore. Does that make sense? I realize that lunch is setting in and I'm boring, so everybody's kind of like, anyway, and there's also statement mode. Don't use transactions if you use statement mode. That means every time you issue a statement, PGBouncer might hand you a different connection in the back.
Does that mean somebody else could end up with your temporary table?
Yes. So you need to pay attention to these things. In the Java world, most of the time, which is kind of where the connection pooler thing was really big first, at least as I understand it, in the Java world, you explicitly have to release connections, which is why Raytheon managed to screw me over the way they did. You explicitly have to say, okay, I'm done with this connection now. And that's nice in that you aren't going to run into problems with somebody else getting your temporary table unless you do something that's entirely your fault. But it's also a pain because you have to remember to explicitly release that, or you get some poor schlub like me on the carpet at 4 in the morning. Yeah?
So in specifically a Django app situation,
Mm-hmm.
would you think of setting this up on a particular machine? Like, would you put it on your database server, or would you set one up on each of your web hosts so you're connecting to localhost and you have a very quick localhost connection?
Folks have done it several different ways. Right now, obviously, I'm putting it on the database server, but you wouldn't be running on crappy VMs anyway. So I've seen people put it on their web servers, and that's been very helpful for folks whose web servers really initiate a ton of connections all at once. I've seen people put up a dedicated PG bouncer box where, if time permitting, which it's probably not, anyway, you have one PG bouncer box that confronts several database servers, and if one of those servers goes down, you can have this failover mechanism to bring up the other and to switch PG bouncer and say, hey, this is now the master database. And then it's, other than the however much downtime it takes for that switch to happen, the switchover happens automatically. So it might be good for you to have PG bouncer on some other box. What I'm getting at is it's valid to do it several different ways. And there are good reasons for any of those different ways. If I can get out of here, let's quit talking about PG Bouncer for a minute. Another thing we want to do, you do want to do this, I promise, is you want to monitor stuff. You want to have a good idea of what's going on. A couple of years ago, I would say this is like the canonical, the one and only way to monitor Postgres. That's probably changed somewhat, but this is still the major way of doing this kind of thing. It's called Checkpostgre. I can blow its horn too because Endpoint writes it. So this was another Ubuntu package, and Checkpostgre is one big script that when you install it sets itself up as a bunch of symlinks with different names, and it's smart enough to know what name did you invoke me under so that I can do what you mean. So for instance, Checkpostgre can check all kinds of things. For instance, we can check how many connections do I have open, or what is the size of my database, so that if I have some monitoring system and I want to watch how big my database grows, I can do that with Checkpostgre. This doesn't happen so much anymore, but in previous versions of Postgres, it was fairly common to disable certain database triggers. A trigger is something that runs automatically when you do X, Y, or Z, and there were good reasons for disabling those, but sometimes people forgot to enable them again, and so it's good to have something that checks to make sure your triggers are enabled. Anyway, we can check all of this stuff, and it all happens pretty automatically. So we're going to show this off just a little bit. Let's check for disabled triggers. It has fairly sensible defaults if I'm connecting just to a local cluster running on default ports as a Postgres user. I do need to tell it some warning level. So in other words, raise a warning if there are more than X disabled triggers. I don't have any triggers in my database, so that was a pretty easy one to check. Let's see. Idle transactions are something that, at least in Postgres, is important. When you log in and you start a transaction, and then you sit there for a while without closing your transaction, that gets to be a problem for maintenance reasons that I won't go into in any great detail. But think of it this way. If you log in, you start a transaction, and then something you do in your transaction locks something in the database. That lock will be held until the end of your transaction. So presumably you don't want to hold it very long in case somebody else happens to want that lock. So don't walk in, open a transaction, lock something, and go to lunch. This will check that kind of thing. People have this problem all the time in their applications, is that their applications will forget to commit a transaction, or more typically, they're using some ORM, and their ORM tries to figure out when's the best time to start a transaction and when's the best time to stop one, and it gets it wrong. That happens quite regularly. And so people will have to pay attention to this, and they'll have to dig in their code and figure out how to, when this transaction is not getting closed. And in the meantime, all of these locks and other maintenance nightmares are building up. So this is something important to check. If I happen to go over to my Bravo system, and I can't connect there anymore. Oh, that's right. Anyway. Okay, well, let's just do this. Let's see. Okay, I have started a transaction. I have done something. And now I'm going to do this. And now it tells me that I have a transaction open. Did that make sense, what I just did? Okay. I have a transaction open. That's a problem. I'm going to roll that back. I run this again. It says we're okay. Yep.
Are these Nagios?
They are. They are. So Checkpostgres will support a couple of different output formats. By default, it's designed to work with Nagios, whatever, anyway, that thing. And all of these, every one of the different actions, and there are a lot of them, like you saw, that Postgres can, or that Checkpostgres will monitor, all of them have some Nagios output format. And they tend also to include statistical information in there too, so if your Nagios is really exciting and can draw graphs and pretty stuff for you, that will just work. This will also handle a couple of other output schemas for different sorts of software, and it's pretty easily machine parsable if you want to wrap it in something. Too many terminal multiplexers. Let's see. So next on my little list. Okay, so you've got your database. You've got it all super secret and secure. You've got it monitored. Now you probably want a backup. So we're going to... I'm going to create a new database. PGBench is a benchmarking utility. I'm not going to bother about that. And it's useful only because, at least in this instance, only because it establishes a database. Rather, it sets up a database schema, objects within the database, and it can query those in some intelligent way. So I've just initialized it. And we'll run PGBench, and it does a couple of queries, and my database works. So now I want to back it up. The easy way to do this is something called pgdump. pgdump creates me a whole bunch of SQL, and if I run this in a brand new database, it should, in theory, PGBench has really exciting data, can you tell? In theory, it should create a new database for me, exactly like the one that I dumped from. Anyway, there's more stuff at the end of this, and I typed that wrong. And the problem is that PGBench can be slow. If I load 400 lines into a table and then 4 million more because I want an actual big table, and then I need to create an index on that, the database that it came from already had the index. It already knew that everything was sorted, and it already had this index. But I have to recreate it from scratch when I'm restoring the backup because I used pgdump and all I have is SQL. If I have a constraint on my database, like this field can't be null, and there's 10 million rows in my table, if I add those 10 million rows to the table and then I add a not null constraint, I have to check all 10 million rows, even though the database that I came from had the same constraint, and I already know that it's valid. So a nicer way is binary backups. So we have this thing called PG-base backup. We'll make a directory for our backup. Again, all of these just come from packages. This is nothing that you have to script your own or build from source. We want it to show us progress. We want it to create a recovery file so that when we restore this backup, it can do some nice, exciting things for us that we may not have time to show off. And it's going to say, oh, I can't do that because, again, we have some PGHBA changes to make. It's the first one down. You'll start dropping like flies after this, I promise. Thank you for coming. Let's see. PG-base backup uses a special type of connection called a replication connection, and we need to allow those. And I'm just going to say trust. Now, I've done that, and now it's going to complain about 2 or 3 other things. Like that I didn't get my anyway, I didn't get my replication connection right. We're running out of time, and so I'm not going to go through step by step how to make this exactly work. I'm starting to tempt the gods of the live demo anyway. The point of PG-base backup is that it creates for you what's called a binary backup. You have your 300 gigabyte Postgres database, and instead of creating a SQL file that's nice and compresses down to 10 megabytes and takes 3 days to restore, instead you have a 300 gigabyte backup that you can restore in about 5 minutes. You don't have to re-add all of the constraints. You don't have to do all of those things. PG-based backup is spiffy because it does this for you. There are other spiffy ways that I was hoping to get to, but I've been too long-winded. I want to emphasize that when you do these backups, especially a binary backup like this, please test it somewhere. Have you ever had that problem? Anyway, I have this customer that I was working for that for a couple of weeks, their backups quit working and they didn't know about it, which got to be a problem real fast when things died. This is something you have to pay attention to. Have a server, restore your backups. These binary backups are very helpful and very fast. The problem is that to make them work, you have to have a lot of files, and they have to be exactly the right files, and they have to be in exactly the right place and named exactly. I told you. They have to be named the right way, and if they aren't there, or if they're messed up a little bit, or if you've got some of your settings wrong, they don't work. So please test this often. I was hoping, and we're not going to get there, to talk about one other bit of software called Rep Manager, REPMGR. I will just talk about it rather than show it off. Well, I can show off a config file, because of course we all like to look at config files, don't we? Rep Manager is a fun little piece of software in that it will create these backups for you. It will create, let's see, backing up a little bit. Another cool thing about these binary backups is that that's how you do replication in Postgres. You have your running database right here that's 300 gigabytes, and every change that happens in it gets streamed over to this other database right here that you've set up with something like Rep Manager. So instead of doing this manually, you say, Rep Manager, create me a new standby database, and it does, and it's sitting right there, and you use it and run it. So Rep Manager is pretty cool. I can say, here's my master database, here are my 13 standbys, here is a database that I call a witness, and the witness's job is to kind of corroborate when these 3 standbys say, hey, I think the master's down, the witness can say, yeah, I think it's down too. And they all put their heads together and say, okay, we're going to promote you to be the new exciting master database. And again, this was, well, they're coming back. That's cool. Yeah. Or the next guy has food or something. See, now we've gone up in number. We're +1 from where we started. Rep Manager lets me have a whole bunch of servers kind of confab and say, look, you've gone down. We need to promote somebody else. And by the way, here's this custom script that somebody wrote for me that goes to tell PG Bouncer that the master has gone down. So now we're going to tell PG Bouncer that the new master is here. Does that make sense? And that way somebody can axe the server, and it all is supposed to come back up automatically. And then when it doesn't, you've got more serious problems than what you started with. Any questions at this point? Awesome. Y'all are falling asleep. Thank you for being a lovely audience. And sorry I didn't get to Rep Manager.